With equilibrium constants, if we know the equilibrium constant for a particular reaction at a particular temperature, we can analyze the reaction vessel in front of us and determine if that particular reaction has reached equilibrium or not. Again, because sometimes reactions will proceed very, very slowly. Sometimes you can't tell if they're finished or not. There may not be a lot of visible bubbling or a particular color change with a reaction, and so it may be very difficult to tell if it has reached equilibrium. So the way you can do that is to measure concentrations and compare it to the equilibrium constant to see how it compares and to see if it matches up. If the number that you calculate matches the equilibrium constant, then you'll know the reaction is finished, it has reached equilibrium. And if it's not, then you're going to be able to determine which way it still has to shift in order to get there. So again, I've got a couple sample problems to work if you have your sheet in front of you. A chemist is studying the following reaction. So nitrogen gas plus oxygen gas yields nitrogen monoxide. She knows that the equilibrium constant for this reaction at this temperature is 0.05. Notice there are no units on this particular equilibrium constant. Now, she has measured the concentrations of each substance, and they are as follows, and they're listed there for you. We're supposed to determine whether the reaction has reached equilibrium yet, and if it has not, we're supposed to determine the direction it will shift in order to reach equilibrium. So first of all, let's figure out if it's reached equilibrium. So we have to start by writing our equilibrium expression. So our equilibrium expression is going to be the concentration of the nitrogen monoxide squared over the concentration of the nitrogen times the concentration of the oxygen. Everything is in a gaseous state, so there's nothing in this particular equation that we're going to leave out. Okay? With the concentrations that we have been given, the nitrogen monoxide is 0.020 molar squared. And the concentration of the nitrogen is 1.5 molar, and the concentration of the oxygen was 1.3 molar. And so, therefore, I probably shouldn't have put an EQ here because I don't know if I'm in equilibrium or not. When I calculate this, and you type all this into your calculator, you should get 0.00021. When I compare that with what I know the equilibrium constant to be, I can see that they don't match. So I am not at equilibrium. The question is, which way does the reaction have to shift in order to get there? So the easiest way to figure this out is to pretend that you have a number line. And so if you plot those two numbers on the number line, just in a general location, we're not going to be super exact about this. The 0.05 would be here. This is what I'm trying to reach. The 0.00021 is much less than that, so it's going to be down here. So if I look at this on the number line, I would have to shift to the right. And so in a very similar fashion, that means that my reaction will also have to shift to the right or towards the products in order to actually reach equilibrium. So this one is not at equilibrium, but will have to shift toward the products in order to reach equilibrium. Okay? So reaction's not done, still has to shift towards the products. Okay, then I have a second example, and so let's look at this one as well. She's same chemist studying the same reaction, but different concentrations this time. And she measures these new concentrations, and we want to know if it's at equilibrium under these particular conditions. So again, same reaction, so it's going to be the same equilibrium expression that I used before, but now I have new numbers to put in here. This time, the NO is 1 molar, and that's going to be squared. And the concentration of the nitrogen is 0.1 molar. The concentration of the oxygen is 0.2 molar. And so when I plug all those numbers in this time, I get 50. Now, this may initially strike you as odd, but we can manipulate reactions to shove them past the equilibrium point. And we're going to be talking about that within the next couple of days here as to how you can manipulate a reaction to force it to go beyond equilibrium, to force it to go one direction or another. So in this particular case, if I would plot these on a number line, the equilibrium constant is 0.05, and so it's right here. That's what I'm aiming for, but the 50 is way up here someplace. Okay, so this is much greater than the equilibrium constant. So just like this would have to shift towards the left in order to get back to the constant that I'm looking for, this reaction will have to shift back toward the reactants in order to reach equilibrium. Okay, so not a whole lot of new material here. You're still calculating equilibrium constant, but this time you're just comparing it to a known equilibrium constant to see if it matches. Is it at equilibrium, and then which way will it have to shift in order to get to equilibrium if it is not already there?